Hello, and welcome to the next video in our series on reaction stoichiometry. This one we will convert from grams of one substance into grams of another substance. And time allowing, we'll go through multiple methods of doing so. Alright, so the key to this is having the correct balanced chemical reaction and then also being able to calculate molecular mass. So if you do not know how to calculate molecular weight, then please consult one of our other videos that goes over that. Alright, so how many grams of oxygen are required to burn 92.6 grams of propane? In another video, we figured out how to break down these words and know what the balanced chemical reaction is. So please refer to one of those videos. We know that it's C3H8 plus O2 gives CO2 and H2O. Propane is C3H8. Alright, so I'm going to balance the carbons, balance the hydrogens, and then balance the oxygens last. Alright, now we'll look at, before I go into one of these methods, I want to slow down just a minute and write down what I'm given. I'm given 92.6 grams of propane, and I want to find how many grams of O2. Alright, so let's look at the first method here. I'm just going to call it method A. That's just a reference name to say it's different than method B or method C. Alright, so method A is sometimes known as the fence method or the train track method. I've heard all different kinds of names for it. We have how many grams of O2 for 92.6 grams of C3H8. And I've got to squish these all in, so it may get a little messy here. First, I've got to get rid of my grams of C3H8. Alright, and I need to get it into moles of C3H8. Now, what do I know that has moles per gram or grams per mole? Oh yeah, molecular weight. So I calculate that for C3H8 and I get 44.11 grams per 1 mole. Now when I divide out the grams, I end up with moles at this point. So I've gone from grams of C3H8 into moles of C3H8. Great, that's where I am so far. If I stopped there, I would have moles C3H8. I don't want moles, I want grams of O2, so I need to use the mole-mole ratio, and yes, that's the only way to get there. To change the molecule from C3H8 to O2 is the mole-mole ratio. Alright, so now I'm going to use the numbers from the balanced chemical equation. I see in front of the O2 is a 5, so I'm going to put that 5 there, and in front of the C3H8 is an invisible implied 1. Alright, now if I were to stop there, I would have the moles of O2. Oh, that's still not what I need. I need grams. So I'm going to keep going. I'm going to put moles of O2 on the bottom and grams of O2 on the top and think to myself, is there something I know that's grams per mole? Yes, indeed, molecular weight. And it is O2, not just O, so it's 32.00 per 1 mole. I usually go 2 places past a decimal. It does me well in most cases. Alright, so scrolling up just a little bit, my grams of O2 ends up being 336 grams of O2 are needed. And that's method A. Let's look at another method. Oh my goodness, that's so much fun. Oh, what did we do? We went from grams of C3H8 to moles of C3H8 to moles of O2 to grams of O2. Cool. Alright, method B. We're going to need to put in our next video. I just can't talk fast enough. Alright, so let's spend just a few seconds to look at this. We changed our grams into moles as our first step using molecular weight. So the first step is to get to moles. Alright, then once you get to moles, you do the mole-mole ratio, and then get to whatever you're looking for. In this case is grams, and to go between moles and grams, we always use molecular weight. Thank you, and hope you watch the next video as well for methods B and C.